So we're doing compositions of functions. Have y'all done those before? So it's basically just like where you take one function and plug it into another one. So we've kind of been doing a little bit of that already. Like when you had to find f of x plus h, that's essentially like the same idea. You're taking one function and plugging it into another. So that's what we're going to do with all these. So the first section that we have is just plugging in numbers. So that's a bit easier. Later we'll have like expressions, so you're not exactly solving it all the way down. So it's a little bit different, but still the same concept. The thing you have to remember is to work from the inside out. You ready to try some? Okay, cool. So if it's written as this, it's the same thing as f of g of 1. Does that make sense? So that little circle is just like an of. It tells you to do composition. I'm sure there's like a fancy name for it, but I don't know what it is. So we're going to go from the inside out. So we've got to evaluate g of 1 first. So g is 4x. So if we plug in a 1, 4 times 1 gives you what? 4. So really, we want to know what f of 4 is. So then we'll look at our f function, and we'll plug in a 4. So we'll have 2 times 4 squared minus 3. Everybody still with me so far? Do you have questions yet? Alright, so what is 4 squared? 16 times 2 minus 3, 29. So that whole thing, our final answer would be 29, not 22. Questions? Alright, so the next one, it says g of f of 2. So I'm going to rewrite that like I did over here. So it's g of f of 2. So we need to find f of 2 first. If we get that answer, we'll plug it into the g function. So if we plug in a 2, I'm going to come over to the side and find f of 2. Can y'all see all that? So we've got 2 times x squared minus 3. So we'll have 2 times 2 squared minus 3. So 2 squared gives us what? Times 2 minus 3. So f of 2 is 5. So really we're looking for what is g of 5. So then we'll go plug 5 into our g function. Gives us 20 for our final answer. Are we okay? If I'm going too fast, y'all gotta tell me because I forget that y'all don't have it in front of you. Yep, I'll slow down. I'm sorry. Can we see everything? Do I need to like zoom out, zoom in? It's good. Okay. Let me know when you're ready to move on.
So how do I know that the f of g then it's g of f? Which one do you plug in for which one?
So like for this one, g of 1 is on the inside, and you got to work from the inside out. So we plugged a 1 into the g function.
So whatever g of like g of f of g would be the inside.
Yeah. So that's why I rewrote. Does that make sense? So this is f of g, g on the inside. G of f, f on the inside. Yeah, the second one is on the inside.
So whichever one's on the inside, you plug that one into that one, and then once you get that, you plug it into
Yes. And so if you have like 3 of them, you'll do the last one. So if it was like, you had f of g of h, into H, plug it into G, then plug that into F. So you're working from the inside or like from this side over.
So it could be like 220.
Yes. Everybody's right. Yes, that way, this way. Any other questions right now? All right, so the next one is f of 2. So we're going to find what f of 2 is, or sorry, of negative 2. And then we're going to plug that back into the f function again. So if we plug in a negative 2 squared is still going to give you 4 times 2 is 8 minus 3 gives us 5. So we're looking for f of 5 now. So 5 squared will give us 25, times 2 gives you 50, minus 3 gives you 47. Is it making a little bit more sense? Do you have any other questions right now? Anybody still like not lost? Or anybody still lost? Okay, so the next one is g of negative 1. So we're going to plug negative 1 into our g function and get an answer. Then we're going to take that and plug it back into the g function again. So our g function was 4x, so 4 times negative 1 gives you what? So we're trying to find g of negative 4 now. So if we plug in a negative 4 4 times negative 4 gives us what? Negative 16. Final answer. Questions? There's a lot of chatting, so I assume that you're experts now, right? Okay. So the next section just tells you how to do it in your calculator. I don't think you're gonna have to do that, but it's like something fun to play with. Do we want to do that or no? Okay, we'll skip that. All right. So the next part, I'll let you write your functions down, and then we'll go find our propositions. So for this section, we're not plugging in numerical values, but we're just going to find, like, what is f of g. So if we do a composition of just those two functions, what is the resulting function? So.
I would have found that as an X, because I don't even know what that is. It's a squiggle.
I'll give them the benefit of the doubt. It kind of looks like an R. Like a lowercase r.
So it's your problem. It looks like a squiggle to me. I'd be that
It's like-
teacher.
Yep. Are we ready to try these, or are we still writing down?
So you want me to check if you're done or correct?
Yeah. Oh, we're doing all of it. Yeah. But you'll need a lot of space for C, so I wouldn't write down D yet. My writing got really, really slow, like my original copy. I was like, oh no. Are we okay to try them? Section C? Yeah? Okay. So, If it says f of g again, that means you're going to take your g function and plug it into the f function. So everywhere that we've got an x here, we're replacing it with 2x plus 3. Okay? So I'm just going to say equals, and then instead of x squared, we're going to have 2x plus 3 squared plus 3x. But again, instead of x, we're plugging in that g function, which was 2x plus 3. And then we had a minus 1 at the end. Is that okay? I'm going to write one more thing. I don't know if this is helpful. You could think of it as f of 2x plus 3. I don't know if that helps. But instead of like f of g, it's f of 2x plus 3. Just to remind yourself, everywhere there's an x, you're plugging in that g function, or 2x plus 3. Any questions so far? Alright. So if we have 2x plus 3 all squared, what do you have to do to multiply that out? You gotta FOIL, you gotta do the box. So when you do that, you end up with 4x squared plus 12x plus 9. Then we'll distribute the 3. That's going to give us 6x plus 9. And then we have that minus 1. Everybody still okay? Alright, so from there, what should we do? Just combine your like terms, clean up what you can, and we'll be all done. Questions at all? Are we still okay? Yes, no, maybe. Alright, so for the next one, this time we're going to do g of f of x. So I don't know if it's helpful, but I'm going to do it anyway. It's like you're finding g of x squared plus 3x plus minus 1. So I think for some people it helps to see it written that way so that you're plugging all of this in place of every x here. So from there, you'll just distribute, combine like terms, clean it up as much as you can, and we'll be done. There's nothing else you can do.
I'm just gonna mark these wrong because they just got their lines. And they got their circles right.
Questions on that one at all? So are we like getting it, or are we still like majorly confused? We're getting it? Okay, because I can't tell, because you're like having your own conversations, and when I'm asking, we're not really responding. So the last one we've got is g of g there, so I don't know if it's helpful to write all this out again, but I'm going to anyway. So when everywhere that we've got an x, in the 2x plus 3, we're going to plug in another 2x plus 3. So we'll have 2 times 2x plus 3 plus 3. Is that okay? So distribute, combine like terms, clean it up as much as you can. Questions on any of that? Okay, so for section D, have we written that one down yet? Alright, so it looks like we're ready to move on. So we're going to go and do the next ones. So we need to find f of g. So we do have a square root function this time, so we're not going to do a ton of simplifying for these just because there's not a whole lot that you can do. So we'll be doing f of g. So that's really going to be like f of 1 minus 2x. So everywhere that we have an x in the f function, you're plugging in 1 minus 2x. Is there anything that we can simplify there? So 1 and negative 2, what do we get? And that's as far as you can go. Is that okay? Questions? I'm sorry. What'd you say? Yeah.
I thought you could have negatives on the right.
You can't. So if we were talking about this one specifically, our domain would come into play. So then we would say negative 2x minus 1 is going to be greater than 0. Solve, and that would tell you what your domain can be.
Well, we can just leave it like this for now.
Yeah, because it's not asking you for your domain.
Okay.
I don't remember if your homework asks you for that or not, but if it does, that's what you would do. Is that okay?
So it's
We'll cross that bridge when we come to it. Yeah. Okay. So the next one we're doing g of f of x. So g of f. Is it helpful to rewrite this out?
Yes.
Okay. Just checking, because if it's not, I'm going to stop. So we're using our g function, and everywhere that we have an x, we're going to plug in square root of x minus 2. So we'll have 1 minus 2 times the square root of x minus 2. Is there anything we can do to simplify that? I'll just leave it. Nope, because it's 2 times all that square root stuff, so it's attached. So there's nothing else we can do. Is that okay? I'm going to rewrite it without the parentheses because I think it's a little confusing to see it with those parentheses. But yeah, there's nothing else you can do to simplify that, so you can just leave it.
Doesn't the square root act like parentheses?
Yeah, it's almost like a grouping symbol on its own, putting all that stuff together. Yeah. Questions? Okay, cool. So we'll do the next one. It's g of g. So we'll be finding a g of 1 minus 2x. So when we go plug in for all that, you're going to have 1 minus 2 times 1 minus 2x. Questions on any of that? So we're still okay? Alright, so I have a lot more on the back, but I don't necessarily think we need to do it all if y'all are feeling comfortable. So look at the functions because they're different. So if you want to do one of those just because it's a different function family, we can. I do think we need to do one of these because you've got a square root and a squared, so what might happen somewhere? Cancel out, right? So, which one do y'all want to do? The first one? Okay, so we'll do this one. So we'll do f of g. I'm going to give you a second to get those functions written down. Does that look blurry to y'all?
Yeah.
Is that better? We'll do 11 and 13 here, so if you want to write 13 down as well, I think we do need to talk about that one. Yep. Yeah. Sorry.
Why is she putting 2 dots?
I think 0, and then counting away from that maybe.
Oh, I don't know. I counted them wrong because
You can't tell it's supposed to be as wrong. I'm sorry. Are we ready to try this? Do we have them written down? Okay, so for 11, we're doing f of g. So f of g. So everywhere that we have an x, we're going to plug in the square root of x minus 4. Do we notice anything yet? Just looking at those two functions?
They're gonna cancel out.
Specifically, those two functions. Do you notice anything yet? They're inverses, right? So what do you think is going to happen when we do a composition of inverses? Do we have a guess? A hypothesis? So when we do inverses tomorrow, there's like a theorem about compositions of functions. So if you do a composition of inverses, you're supposed to get x. So let's see if that happens. We're plugging this guy into f. So we'll have x squared. So really it's the square root of x minus 4 squared plus 4. So what happens when you square a square root? Square root goes away, so we're just going to have x minus 4 plus 4 and negative 4 plus 4, and we're left with. Is that okay? So like I said, tomorrow you're going to be asked to prove that functions are inverses. That's how you do it. We okay? So what do you think would happen if we do g of f? Same thing, right? Do we need to do that? Okay, cool. So moving on to 13. We're going to get x again? Why did I write that? That's not what I meant. That's better.
They got their dots right. But I ain't got no apples.
That's wrong. Or you could do half. Do half. So y'all are wasting your own time at this point. You got a lot of homework to do. I was trying to give you class time to do it, but if you talk through the notes, then I mean, it just takes that much longer. So for this one, you're plugging in that square root of x minus 4 into the square root of x minus 4. So when we do that, something funky happens. So in place of this x, what are we plugging in? Have we ever dealt with that before? That's what I figured. That's why we need to make sure we pay attention and go over this one. So if you have a square root under a square root, it's a fourth root. Okay, so that's fine for this part, but we still have to consider that 4 that's off to the end there. So we have to think what would be like an equivalent. So instead of 4, it needs to be like 16, because it's the fourth root of that number. Are we making any sense of that at all? I'm trying to think how to explain this. So because this one's not under a square root right now, we're about to put it under a fourth root. So we have to think what number under a fourth root would give us the same value as a 4 under a square root. So we're trying to figure out what under a fourth root is the same thing as a 4 under a square root. So what is the square root of 4? 2. So fourth root of what number gives you 2? 16. That's where that comes from. Does that make sense? Okay. Is that better? Alright. So that's where this is coming from. How do I write x minus 4? Are we alright with that?
Yeah.
Okay, so then you can do the negative 4 and the negative 16, just a little bit more, just clean that up. And we'll leave it at x minus 20. Call it a day. Questions on that? Alrighty then. So the next section, your functions are 2x plus 3x minus, x squared plus 3x minus 1, and then 2x plus 3. That's kind of just more of the same, so is it okay if we skip that? Alright, so we will do the next section because we've got rational functions there. So I'm going to give you a second to get those written down.
Which math is this?
I would think right. But I'm not completely sure, so hold it off the side so you see if you have it. I told him over and over, but the first line said, little.
Yes. So you've got 1 over x plus 2 and 4 over x minus 1.
Are we doing an H2, or are we just going to stop
Yeah, we'll do those two, but I would leave some space
for H?
for this.
Oh.
Because, like, it's going to end up being compound fractions, and, like, I use a lot of space for that. I put, like, each part on a line.
I didn't know because, like, I was going to, like, split it. I need a lot of
probably leaves the room. Alright, so we're going to do f of g first. So I'm going to rewrite that because I think it's still helpful. F of g of x. So like I was just saying a second ago, because these are both rational fractions, or rational functions, they're fractions. When you plug them into each other, they're going to have compound fractions. Do you remember how to deal with those? Maybe, maybe not. So in this case, we're going to have 1 over 4 over x minus 1 plus 2. Is that okay? So just like regular fractions, anytime you're adding, what do you have to make sure is going on? Common denominator, right? So what denominator do you think we need with this 2? It needs to be over x minus 1, right? If we add it on the bottom, you got to have it on top as well to like balance that out. Because x minus 1 over x minus 1 is like 1, so it doesn't change. Do you get what I'm saying? Yes, no, maybe. Okay. So that's going to give us 4 plus 2x minus 2 all over x minus 1 on the bottom in your denominator. We okay? All right. So when you have when you're dividing by a fraction, what are you really doing? So it's really like 1 times x minus 1 over whatever this simplifies into. Does that make sense? So we can essentially just flip it, and this is all going to simplify to x minus 1 over 4 minus 2 gives you 2, so 2x plus 2. Those guys. That okay? Questions? We good? Yes, no, baby?
Whatever the top number
Baby.
is times the bottom.
We'll see.
Always. Just right now.
Yeah, so if you're dividing by a fraction, you multiply by the reciprocal, so it was 1 times the bottom flipped. So we could just flip the bottom. If it was like 2 up there, it'd be a little bit different. But questions on that? Okay, so we're going to do the same thing, but we're going to do f of f this time. So again, when we want to add those fractions on the bottom, what kind of denominator do we need over here? Plus 2. So if you have it on the bottom, you also have to have it on the top to like balance that out. So times x plus 2 on top. Is that okay? All right. So again, we have 1 divided by another fraction, so we'll multiply by the reciprocal. Just since it's 1, we can basically just flip our denominator and we'll be good to go there. Combine the 1 and the 2. So we'll have x plus 2 over 2x plus 3. 5. Hold on, I didn't multiply correctly. This is a 4. And that's a 5. Is that better? we have questions? Anything we're not sure about? Okay, cool. So for the next section, they're giving you a composition. I don't think you have to write this down unless you just really want to. I think we can talk about it and get enough out of it that we need. So they're giving you a composition. We want to know what was f and what was g. So what did they plug into another function to end up with this? So g is going to be your inside function. F is like your outside function. So we just had to guess. What do you think the inside function is here? Does that make sense? Do we kind of see how that's like inside something else? So then what would your outside function have to be? X to the 50th. Is that okay? Makes sense? Again, you don't have to like write this down because I think it's just talking about it is enough. So then what about the other one? It's a little trickier. It's 1 over x plus 1.
It's probably 1 over x when you plug x plus 1 in.
Yeah, that's exactly it. So your inside is x plus 1. And so then your outside function was just like 1 over x. Does that make any sense?
Yes.
Are we okay with those?
Yes.
I really don't think that's going to be a problem that you have to do like on your exam. So it's just a conceptual thing. Are we good to move on? Okay. The last part. Look at these functions. What do you think they are? Inverses. Do you remember what we said happens when you do compositions of inverses?
Yes.
Do we need to go through that again? Or are we okay? So we're all right? Okay.